Alright, welcome everybody to week 5, day 1. Although it's Wednesday, it is the first day of the week for this class. Today we're going to be talking about void functions and call by reference. Call by reference is often considered the hardest concept in CSI 40, other than pointers, but they are pointers, so the hardest concept. Before we do that, though, I'm going to do a little bit of just announcements. Zybooks has been kind of a grind for some people, and it's deliberately so. I've said it before, and I'll say it again. Learning to program is like learning a foreign language. You have to put in time and effort on it. Like, I was supposed to meet with my Japanese tutor tonight, and so I haven't been studying the vocabulary enough, and so, like, when I was at lunch yesterday, I was going through my flashcards and all that kind of stuff, because you have to put in the time. I've done the research, I've looked at the numbers. Students that like kind of skip the Zybooks do worse in the class than people who, you know, put in the time and effort to go through all the chapters and do all the work. That said, the Zybooks is going to be easing up after now, basically. So next week's Zybook, I didn't give you all of the lab assignments to do. Instead, I gave you half of them. And so, and then as we go forward, the Zybooks are going to get smaller and smaller. In fact, starting in like week 6, the Zybooks are going to be like probably 100 points. Currently they're in the 400 point range, so about a quarter of the size. And there's going to be 2 of them a week. So basically it's going to be kind of parceled out a little bit more. So instead of getting hit by one giant assignment where people start the night before and stay up all night, you know, doing a giant thing, I'm going to kind of space them out, kind of force you to have the spaced repetition and things like that. But overall, the amount of time you're going to have to commit to it is going to be less than in the first part of the semester. Okay? So, and if you didn't get 100% of your Zybooks, don't worry. I do lots of extra credit on this class. I recommend going back through the first few Zybooks again to review and pick up anything you might notice before. Yeah, and the reason why I gave you all of it is because all of it's important. Like, that's the foundation for computer science. Functions is really the end of the foundation of computer science. With everything you know in class, technically you could code World of Warcraft or Microsoft Word or something like that. Now, it's a monumental task. You don't have probably the mental skills to do it. But you've got what you need to know. You know how to do a loop, you know how to do a branch, you know how to do a function, you know how to do input and output. That's all the basics, and it's really important that you don't skip any of that, because all of the basics are very important. It's like if you go into like a martial arts class, you just dip out every time they teach boxing. You know, you're gonna have a giant hole in your personal defense arsenal if all you can do is grapple and kick and you can't punch. All right, so Mincarelli has very generously offered to help with the Zybooks assignments. He told me he does about 80% of them for you. And if you think any of the Zybooks assignments are particularly difficult, message him. He's got a note on chat right now of the assignments that he's going to be putting together videos on, where he works through about 80% of the problem. And so I could probably add them to the YouTube list. They're going to be on Canvas, but for those of you watching this video that aren't in my class, because there is a bit of an audience of people who aren't at our college who watch these videos, which is cool. I can probably link Mincarelli's videos on my YouTube channel as well, if that's okay with you, Mincarelli. Just send me the hyperlink for it, and then I'll put it up on the playlist, and then it will appear for the non-Clovis Community College students that are taking this class. Cool. All right, awesome. All right, so let's move on. So the topic for today, first of all, is a void function. So I got a file called YOLO. What is YOLO? Oh, interesting. It's a dictionary. Interesting. Okay, so let us talk a little bit about void functions. So the functions that we've learned so far conceptually have been like in algebra. You put in a value, and a value comes out. A void function is... Some computer science professors object to the term void function. They want it to be called a subroutine or a procedure, okay? And the reason for that is because it doesn't actually return a value. If you say void, I don't know, chems, then this does not return a value. That's what the void means here. So learning point number 1, void functions do not return a value. Okay? It's always hard to type when I'm at a weird twisted angle like this. Okay, so what does that mean? Well, if you try returning a value, like return 42, it won't work. You can't return a value. It's a void function. Okay? You can return, but you can't return a value. This means quit back to main. And if you try like couting the result of a void function, you can't do that either. Why? Because there's no value to return. If you had a normal function, like if we had a function called like int f, like that, this is basically an algebra. This is like f of x is equal to 2x, right? And so if we did that with like f, we could do f of like 42, and that's fine, because what this means is that you're passing 42 to f, it does some computations, and then it passes back a value, okay? And then that value gets printed to the screen. So everybody, what is this going to print to the screen? If you pass 42 to f of x, what value comes back, and what value gets printed to the screen? Okay, cool. Now, what if we have Bob here? What values get printed to the screen? There could be 2 values now. We're going to print the value of f of Bob. So we take Bob, we pass a copy of Bob's value to f. This is something called call by value. Int x is called call by value, which makes x a copy of Bob. Okay? So that's not Bob, it's a copy of Bob. So it's going to print out 84 and then 42. Good. So even if we do this, x is equal to x times 2, return x, is this going to change Bob? Like we pass Bob to f of x over here, and we're doubling x. Is that going to change Bob? Or is Bob still going to be 42 down here? What do you think? Is that changing Bob, or is it changing a copy of Bob? Bob's doppelganger, Bob's clone. Let's find out. Wrong one. Let's try that again. There we go. 84 and 42. Okay. So, yes, Bob did not change. You see that? We passed Bob to the function, but it clones Bob. It makes a copy of Bob. And so the x that gets changed here, this is not Bob. It's given the value of 42, and then it can do whatever it wants with it, and even though we change it here, it doesn't change Bob back in main. And that's why it's called call by value. You pass the value of Bob, but you don't pass Bob. Bob doesn't go into the function. The value of Bob goes into the function. Okay? Does that make sense? Should be pretty straightforward, right? Pretty self-explanatory. This thing here, though, doesn't seem to do anything. In fact, it doesn't do anything right now. You call it, if we call it schemes, you have to call it like this. You can't put it inside of a cout because there is no return value. Void means there is no return value. There's nothing to return there because there's no return value. It's not even 0. There's no return value. But you can just call the function like this. And so you can consider this and so basically, if you have a bunch of commands you do over and over again, like, I don't know, turn on the reactor, do experiments, 10 times, and then turn off reactor, and you don't need the main the return technically there. Let's say these are functions, and turn on a reactor like turns on some nuclear reactor, and then after it finishes, you do some experiments 10 times. I don't know what this is. I'm just making stuff up. And then turn off reactor. And so when you call schemes, it pauses main, it comes up here, and it runs these three functions. Then it returns back into main. So this is functionally equivalent to me writing this, right? But here's the thing: like, what if we wanted to do this like a bunch of times, like do these three commands over and over again? What we could do is in main we could just like constantly be like, we could do it up here and then do it down here and then like do it down here and stuff like that. But it's really kind of aggravating to repeat yourself like that. There's a principle in computer science, and I've said it before, called "Don't repeat yourself." DRY, dry principle, don't repeat yourself. So I've said it before, but I'll say it again: don't repeat yourself. So you don't want to repeat yourself. So anytime you find yourself doing the same commands over and over again, like this, that's a good candidate for being put into a void function, right? It's the same thing over and over again. So rather than doing these three lines over and over again, we just call chems, right? And then do that, and then do that. So every time chems appears, it's going to run these three commands. Okay, does that make sense? And it's not returning a value. It's not. This one isn't taking any values as parameters. We could have it take value, like as parameter. You can have a function that takes no parameters and returns nothing. You can have a function that returns something but doesn't take any parameters. You can have something that doesn't take any return value but takes parameters, or takes 5 parameters or whatever. So we could do, something like this if we wanted, and then chems, it's like how many experiments we're going to do or something. Does this make sense to you all? So basically, it's a void function is just like a set of commands that you just are going to run. Okay, that's how you should think of a void function. It just has some side effects. It's going to do something. You can't think of it like you think of like an algebraic function, because it's not. It doesn't map into like your algebraic understanding of a function. And like I said, some computer science professors get upset if you call it a function, because it's not a function. It doesn't, behave like a function does in algebra. It's a subroutine or a procedure. I don't know. They have a bunch of weird terminology. So when you guys did the Zybooks, were you given a Zybooks assignment where you had to like print a giant arrow to the screen or something like that? Do you know what I'm talking about? Like, you had to print like a thing. So, what if in your code you had to do this repeatedly? Okay. Like over and over inside of main, you're going to be like printing like that arrow over and over again. Then what your code would end up looking like is something like this, right? Like your main's just going to be like it's just all these print, and it just looks absolutely horrible and unmanaged, and like, what the hell's going on here? Nobody knows anything about what's happening. And so rather than like wanting to print the arrow over and over again in your main, which is just terrible, what you do is you'd make a function like this, where you have the commands to print the giant arrow. In this case, it's going to print chems to the screen. I don't know if you can do that. It's going to print chems to the screen, and it's going to print it X times. Okay, and so the return obviously doesn't do anything here. But it's just useful to see how you can return from a function, like if you wanted to return earlier or something. Okay, so yeah, and so now instead of doing all that stuff, we can do something like this, right? So we run the code. You can see it prints chems once, then it does the 84, then it prints chems twice, then it prints 42, then it prints chems 3 times. Do you see that? It's way nicer to write it like this than to copy and paste the code over and over again, right? Because think about it. Like, what if you had a bug in one of these things? Like Mincarelli did this for me, and it was like it had like an off by 1 error, and like one of the spaces was off by 1. If you had copied and pasted it like 100 times, you have to go through 100 copies and pastes of that code and fix every one, right? It's utter garbage, right? So instead of that, you put, anytime you have repeated code, you put it into a function, and then if you find a bug in it, you can fix it in one place. And then it's fixed in every place. So it's fixed here, it's fixed here, it's fixed here, right? Yeah, printing something to the screen is not returning a value. All right, these are two very different concepts. So when you do something like this, it's as if I had written to the screen here 84, right? That I had written on my code here as 84. It actually replaces the value of the function call. Whereas chems cannot, like you can't do like chems1 plus like chems2, right? Because there's no value of it at all. Okay. So, yeah, the difference between returning a value and printing something to the screen is something that a lot of students have a hard time understanding. Because you're printing it to the screen. Isn't that returning a value? No. Printing it to the screen is a side effect, right? Like you're just running along, you're just like throwing things out to the screen. That has nothing to do with actually returning a value from a function. So what's the point of Bob? I don't know. I can call it something else if you want. Int, I don't know, tuna or something. Yeah. So void, it's not returning anything. It's printing things to the screen, but there's no value being returned back from the function. So this makes sense. So anytime you just have a bunch of lines of code that you want to do, but you don't need it to return a value, a void function is the way to go. Okay? Any questions about this? They're used all the time. Sometimes you just don't have a value to return. Okay. Now that we got that out of the way, let's talk about call by reference. Okay. So here's learning point number 2. So we're going to learn something called call by reference. So this function is, in a certain sense, exactly the same as this one up here. Okay? Except instead of returning a value, it's actually going to double whatever variable is passed in. Okay? This ampersand here makes it what's called call by reference. Not call by value, call by reference. This is by many students considered the hardest concept to grasp. So I'm going to try and explain it in a way that I think is pretty easy to understand. So if you pass Bob to doubler, it does not pass a copy of Bob. Bob himself actually enters the function. And so if you double the value of x here, it's actually going to double Bob back in main. So if we, let me take out all these prints, chems, code graveyard. Okay, there. Keep it simple. So if instead of calling f, we call doubler, note that we can't put it inside of a cout. Why? Because doubler is a void function. It does not return a value. We can do this. Okay? So when we call doubler, Bob himself enters the function named x here, but still Bob. And Bob's value is going to double. And, oh, sorry. Bob's value is going to double. Okay? So when we print the value of Bob here, what value is it going to print to the screen? $84. Good. It's actually going to modify Bob. And that's the difference between call by value and call by reference. If I made this call by value, what is it going to print here? If it's call by value, Bob himself doesn't enter. Instead, the value of Bob, 42, enters but Bob himself doesn't change. So it's going to print 42. But if it's called by reference, any changes made to X are made to Bob. Bob himself enters the chat. Okay? So what if we call doubler again? What value is that going to print to the screen? It's called by reference again. I changed it back this way. So what value is it going to be now? 42 doubled is 84. 84 doubled is 168, I think. And there we go. And if we call it again, Bob's getting big. Bob's big boy. What's it going to be this time? We got 3 calls to doubler. 336. Yep. All right. One more time. Bob's doubling again. Exponential growth, out of control. All right. 672. Yep. Okay. You guys see how that works? So this one doesn't change Bob. This one does. Okay. And it's all about that ampersand right there. The ampersand right there means it's called by reference. That's the difference. Okay? Not too bad. What do you think? Not too bad. All right, so let's learn. We're gonna have to get into some vocab, but let's try this. What happens if I try doubling the value of 100? Do you need the ampersand before X? Yes. It could be here though. It doesn't actually matter where the ampersand is. This is perfectly valid C++. It's horrible, but it's perfectly valid. Okay? So, some people do it one way, some people do it the other way. What does the ampersand do? That means Bob himself is entering the function. Okay, that's what the ampersand means. The ampersand here means that it is called by reference and not called by value. That's the difference. The ampersand means the original variable in main is actually there in the function. So when you double X here, you're actually doubling Bob back in main. That's what the ampersand means. Okay. The ampersand technically, from a technical sense, means the memory address of Bob. So the memory address of Bob is entering the function, not a copy of Bob's value. The address of Bob is clear. Okay. What about int? Yeah, it's all the same. It looks terrible, but I personally, I don't know. I don't really have any strong opinions on it. Okay, so what happens if we try passing in 100 here? Why can I not double the value of 100? Seems kind of weird, right? Why does it not make sense to double the value of 100? Yeah, it's not a variable. So, yeah, it's the number. Like, exactly. Like, you're trying to change the number 100 to be 200? You can't do that. It doesn't make any sense. So, if we look at what COC is saying, it's saying there's no matching function call to doubler. And that's not especially useful as an error message. If we compile the code in G++, we get this. And I told you we're going to be going over a little bit of terminology today. What is this, Fortran? Yeah, in Fortran you can change the value of 100 to 200. It's not recommended though. So, let me read this error message to you. Error. Cannot bind non-const Lvalue reference of type int reference to an Rvalue of type int. So we got that word there. We got that word there. And I guess non-const matters a little bit, but that and that are two words that are in the parlance of C++ programmers. Everybody's supposed to know them. And, well, today's a good time for you to learn them as well. Because if you try writing code and it fails and you get this error message, you need to know what it means, okay? So let's talk about what an L value and an R value are, okay? So does this make sense? I can type. There we go. Like, is this, like, valid C++? Yeah. So what an L value means is which one of these two things appears on the left side of the equal sign? Bob or 10? Bob. Bob is an L value. He's called an L value because he's on the left side of the equal sign. What is an R value? Which one of these two guys is an R value? 10. Yeah. So L values are things that can appear on the left side of an equal sign. And an R value is something that cannot appear. And I'm saying this very precisely, by the way, because Bob can appear on the right side too, right? So R values are values that can only appear on the right-hand side. L values are values that appear only, are the only things that can appear on the left-hand side. They're not mirror opposites of each other. Because you can say like Bob equals Bob. Is that valid C++? Bob is equal to Bob? Yeah. It's a, doesn't do anything. It's like saying Bob is equal to Bob plus 0. Like, yeah. But we do this kind of stuff all the time, right? So Bob can appear either on the left side or the right side. But the only things that can appear on the left side of an equal sign are an L value, and R values can only appear on the right-hand side. You cannot say 10 is equal to Bob. Right? Do you see that? That makes sense? R values cannot appear on the left side of an equal sign. So expression is not assignable. That's a great one. Let's see if G++ L value. Okay, yeah, there we go. So error. L value. See, I'm trying to teach you guys some terminology here, some jargon. Okay? Some technical language. So now you kind of understand what it means, right? Like you can't have an R value on the left side of an assignment, right? Does that make sense? Only L values can appear on the left side of the equal sign. And these terms are actually a little bit antiquated. C++ 11 actually changed the terminology of L value and R value, but they're so commonly used that the compilers actually still use them rather than using the more precise terms. There's now like X value and PR value and G, there's a lot of different R values and L values now, but basically this is the common parlance of the C++ programmer. L value and R value. Okay, so let's see if let's quiz you a little bit. Okay, so is X, is this a L value or R value? X is an L value because it can appear on the left-hand side. Okay, it doesn't have to. You could say, like Y is equal to X, right? L values can appear on the right-hand side, but an L value is the only thing that can appear on the left-hand side. So this is an L value. What about this? Is that an L value or an R value? Doesn't work, right? The results of every expression is an R value, okay? So likewise, think about if this makes sense. Like x plus 10 is equal to... Do you understand? Like, is x plus 10 an L value or an R value? What do you think? Turned off. Uh-oh. Let me see if this has been recording audio. Let me pause the recording for a second. Weird. It must have been using my web camera instead of the my professional microphone. Okay. Yeah. So this thing here is an R value, right? This can't. Nothing that can. No expression can appear on the left hand side, right? X plus y. You know, there. Just think about it. It just doesn't make sense, right? So, what about like the power of like x squared? What do you think? An L value can be on either side, and R value can only be on the right-hand side. Yeah, that's a good way of putting it. So an L value is the only thing that can appear on the left side, and R value can only appear on the right-hand side. And those are not exactly symmetrical statements that I made, but they're true. Yeah, so it's all, you can't, yeah, this also does not work. So if you try compiling it, not in chat, let's try on putty. Try compiling it. X was not declared. Yeah. Fair enough. Wow. Okay. Pow is not declared. I mean, you're not wrong. Okay. That's not the point I'm trying to get across, though. There we go. Error. L valued required. See? So, same thing. Okay, so when we were doing this thing here, passing in 100, it's complaining at us that you're trying to pass, you're passing in an R value, and it can't bind to a L value reference of type int reference. So you cannot pass in an R value when you're expecting an L value reference like that. So only variables can be passed in. I mean, think about it. It makes sense. Like you're essentially doubling the value of the variable, and this is in a variable, right? So it can't work. You guys with me on this? Like, the only tricky bit here is the error message you get is going to be weird if you don't understand what an L value and R value is. Okay. So we could make this work actually by making a const. So you might see a little clue here, cannot bind a non-const L value reference. So if the thing's const, what happens is if it's const, it can't change, right? So you can actually pass in 100 because you're guaranteeing this number here is a numeric constant. You're guaranteeing it can't change. So C++ will actually make it work. So somehow. So this will actually be fine. And if you like, I don't know, see out X the screen, it'll print 100. Okay. So it'll work if it's a constant, but it will not work if it is by reference. Okay. So const is, we talked a little bit about it. We'll probably talk more about it in the future. But const basically means the variable can be read from, it cannot be written to. So if I was making this variable here, I'd probably just make it call by value. Less hassle. Okay. So we do call by reference, at least right now, when you want to pass in a variable that's going to change. Okay. So we put it back the way it was. X is equal to x times 2 int reference x. And now you're going to do a little bit of lab time. Let's pass in Bob. So for your lab time today, you are going to make a function that triples the value of the variable passed in. Use call by reference. 2, make a swope function. Can't call it swap. Call it swope. That takes 2 ints by reference and switches their values. Example, swope xy will give x y's value and yx's value. For number 3, do number 2 this time without a temporary variable. The way that most people implement a swap function is by making a temporary variable. So they make an int temp, and you can make variables inside of functions. That's fine. Int temp, you can make variables inside of functions, just fine. And so they do something like temp equals x, x equals y equals temp. So for number 3, do that without a temporary variable. Okay. And so I'm going to give you guys 15 minutes or so. And let me just take a look at what I did in the earlier class, make sure I covered everything. Take the function prototypes I should probably cover. Oh, and then Vim stuff too. Yeah, okay. Yeah, okay. So before I turn you loose on that, there's a couple other learning points to talk about. First of all, we got this function named chems, and it's down below main now. Now, some people asked last time, like your functions always have to be above main. And by default, the answer is yes, right? Because the compiler kind of goes through a line at a time. It's like, oh, I know about a function named f, Oh, I know about a variable named x, things like that. That's why, if you want to have your brain hurt, this is valid C++. Just take a look at that. Just admire that for a second. We're making a new variable named Bob of type integer. And what value are we giving it? Bob's value. But what's Bob's value? Bob's value. But huh? Yeah, this is undefined behavior. But it's valid C++. And that blew my mind the first time I saw that a couple of years ago. It's like, what? Huh? What? What? Because it doesn't seem like it should be possible, but it is, because the way the compiler works is it goes through, and as it sees things, it's like, oh, I've seen it. I know that thing exists. Its type is integer. And so by the time we get to the right-hand side over here, it's seen the fact that there's a new integer named Bob of type integer, and it's like, okay, well, clearly you know what you're doing. So this is the exact same thing as leaving Bob undefined, right? So probably better to just do this, but if you want job security, nobody can fire you when you write code like that, because they will be afraid to touch anything you write. Yeah, okay. So where was I going with that? So the main requirement for C++ is that it's kind of seen something before you can use it. So if I wanted to call chems right now, pass in, 2 or something. So that I want it to call chems here with a value of 2, which means we've got a for loop here. For loop's going to run 2 times. It's going to print chems to the screen twice. Okay. Notice the compiler does not like this. And the reason why it doesn't like this is because it's never seen chems before. It's like the Loki meme. I've never seen this man before in my life. It's never heard of chems. By the time the compiler's gotten here, it has never seen or heard of chems. So what do we have to do? Well, if you want the function below, that's why by default I kind of put things above main so you don't have to do this. It's a little less typing. But if you want functions below main, and a lot of people code that way, and they're not wrong either. There's arguments to be made either way. I personally have no strong opinions on it, but a lot of people like putting all their functions down here below main. And so if you do that, then you have to do what's called forward declaring your function. So this is called a forward declaration. And you basically just pinky swear and tell C++ there is a function named chems that takes an x as parameter and returns nothing somewhere. That's literally what you are telling C++ is that somewhere in your code base, it doesn't even have to be in this file, somewhere in the code base, somebody has written a function called chems that takes an integer x as a parameter and returns a void, and technically you don't even have to give it a variable name. You can do this. That's all it needs to go on. So that when you get down here to main, and main is like, oh, you're calling a function named chems, and it takes an integer. Have I ever heard of this before? Oh, yes, I have. The user has told me that somewhere within the code, there is a, this thing exists. And then by the time you get down here, they're like, oh, it's that guy. All right, cool. It works. I promise this exists. Trust me, bro. Now, here's the thing. It doesn't have to exist, right? Now, let me show you it working first, and I'll show you what happens if you break the promise. Okay. Bob is used uninitialized. Yeah, I know. That's the point. And so you can see it prints out chems twice successfully. We call it here. It's heard of it because of the for declaration, and then by the time we get to the end, it's like, oh, it's that guy, and then everything works. Okay. Now, what if I told you there was a function named, I don't know, reams? Okay. This compiles just fine. There is no function called reams. Okay. There is no such function. I pinky sworn, I told it, I promised it that there is a function with this name, and there's not. And you know what? It'll actually compile just fine. Okay? It won't run, and it won't build an executable. So it might be a little bit too technical for you guys in your fifth semester or fifth week of computer science, but there's actually a step after the compilation step where it goes and it calls all of your chips in. So if you promised it that a function called reams exists, after the compilation step is something called the linker step. And the linker step is where it goes and it tries to locate all of the functions like in your directory, like maybe this is in a different file or something, and it goes and it tries to put them all together. Okay? And if you do this, you're going to get a linker error, not a compiler error. Okay? So let's try compiling it. We got a couple warnings here. Bob's being used uninitialized, right? That's all unrelated. And then here we have a linker error. So LD is the linker. And it's saying in function main, there is an undefined reference to this reams person you told us about. It's supposed to take an int. It's named reams. I can't find it anywhere. And it quits. And it does not build your program. This is technically not a compilation error. This is a linker error. Okay, and so that's one of the reasons why I don't use for declarations, because what happens if, like, what happens if I'm doing this kind of stuff and then I'm like, I want this to work on a float instead of int, you know what I mean? And then, like, maybe it links, maybe it doesn't. Nope, it doesn't link, right? You know what I mean? Like, it's one of those things where, like, for me, for declarations kind of add like an extra layer like of indirection where things can go wrong, and I don't like that. And every time I change something down here, then I have to go up to the top of the file and change it here. And if you ever forget to keep those things in sync with each other, then bad things happen. So, I'm not a huge fan of for declarations, but a lot of people code that way because they like to have their main at the top. And so the first thing you see is main, and then it's going to call into different subroutines and things like that down below. So coding style, it's up to you if you want to do it this way or not. I have no, like I said, I have no strong opinions on it. You will see me in this class, and most of the time, having main at the bottom of the file, just so that I don't have to type things twice, because I don't like repeating myself. Okay, I don't like repeating myself. All right, so yeah, let's do a little Vim magic. Okay. So Vim techniques. So front slash, and then a keyword searches for that keyword. Okay. So if I front slash chems, then all the places in the code where the term chems appears is highlighted in yellow, right? And I can hit N, and it goes to next. Shift N goes backwards, lowercase n searches forwards. And so by using n, backwards n, and the search stays. Like even if you're doing other stuff, that search stays. It stays highlighted until you hit enter, and then it clears the search. Enter is not standard Vim, by the way. It does a no, which means no highlight. Before I bound that key, every time I do a search for like chems or something like that, and I would get annoyed at like the highlighting being permanently on, then I'd have to do a search for like some random thing, and then it would say pattern not found, but then it clears the highlighting. So what I ended up doing was binding enter key to no highlight, and then it just turns off. It just turns off the search. 6S. Delete the next 6 letters and enter insert mode. And obviously, 6 can be however many you want. So, like, let's say that I want to switch the name Chems to like Portnoy. Okay, so I can type 6S and then Portnoy. Okay, and then I can hit N. Chems. Okay, I can hit dot. And dot does the last command that I just did. And that's really, really useful. It's an automatic macro. Whatever the last command you did in Vim was, dot will do it again. It is super, super useful. Again, I don't know how people can code using like Notepad or Visual Studio, which is like Notepad essentially. It's like a glorified Microsoft Word for coding. It's horrible. Unless you use the Vim plugin for it. Dot, right? But you can do search and replace, yeah. I used to search and replace in code, and then I got more experience, and I don't search and replace anymore. You know, if you search and replace float with double, like, oh, look, it's, you know, just easy. Search and replace, done. 275 instances of float have now been replaced with double. How confident are you that all those things were actually correct searches and replaces? Because you will see in code things like saying, I'm going to go eat a root beer double. Right? So, you know, anytime, you know, I'm going to go double on the pool. I'm going to go double in my inner tube down the river. Like all these places where the word float appears that's not actually referring to the float type have now been changed to double. Search and replace is incredibly dangerous. Visual Studio has a refactor tool, which is nice, and I also don't entirely trust it. So, so you can like change the name of a variable, and it changes all instances of the variable up to a certain point, and then it fails, and yeah. So, so my workflow is to search for the term that I'm trying to search and replace. I hit N to go to the next one. I use 6S or however many letters it is and type the new term. And then I do the search and replace. And then I hit N to go to the next one, and then I hit dot. Then I hit N to go to the next one. I hit dot, N to go, and I'm looking at each one to make sure that I'm not screwing up somehow. Like I used to do blind global searches and replace, and it is painful experience that has taught me not to do that. Instead, I look and examine every single thing, making sure that if that search and replace should actually take place. And so I just go next, dot, next, no, next, you know. And Vim has that ability. There's a search and replace functionality in Vim. I like doing it manually. Because it locks you into that mode when you're in search and replace mode. And I like being able to scroll around and look at things and then hit N to go to the next one. It's Microsoft Word if you don't have Office 365. Yeah. Okay, Vim is nice when you know the shortcuts, yeah. And you gotta know the shortcuts. It's just how it is. Okay, so I'm gonna give you guys 10 minutes and you gotta do lab time. So essentially be very close to doubler, write a function that takes a variable by reference, the ampersand is very important, and triples the value. So don't call it doubler, call it tripler. I don't know. And it's going to be very close. It's going to be very close to what we have on the screen here. You should all be able to do that one pretty easily. And then after that, make it swap function. Can't call it swap. Swap's already taken by the standard library. and make a swap function that switches the two values passed in, and then do it again, that time without a temporary variable. All right, I'm going to go ahead and pause the stream now and come back in 10. Okay. All right, let's take a look at some answers here. So what do we got going on? Triple, yep. So the tripler is going to take an x by reference and triple it. So you take in user input, and it'll triple and print it. Okay, that looks fine to me. Taking two things as input, switch their output, their values, and then output them. So swap with a temporary variable, temp equals x equals y equals temp, and then using algebra is correct. That's how you do it using algebra without using a temporary. So yeah, very good job. Yeah. I can't find any flaws with that. So the only thing I would do differently is I'd not have the return 0 because it's not necessary. But most people put that in to your code. So cool, very well done, Noah. Let's take a look at Otal's code. CMath isn't really needed, but I would probably indent this here. GG equals capital G is everyone's friend. So if you've got your code like not formatted properly, what you need to do is do GG equals capital G, and that formats your entire document. Write that down here. GG equals capital G formats the whole document. Very useful stuff there. It helps you find bugs a lot of times, because like if you have an extra curly brace somewhere or forgot a curly brace somewhere, then GG equals capital G will make the problem very obvious because everything's indented or unindented. Okay, using say standard, I guess is fine. Swope 1, haven't finished. Okay. So yeah, this one isn't finished either. You can't say temp x. So right, so so let's just do this. Void swope int by reference x, int by reference y. So the traditional way you do a swap is you say integer temp equals x is equal to y, and then y is equal to temp. So it's playing like a little shell game, right? Like you have three variables, and x goes into temp, and then y goes into x, and then temp goes into y, and then at the end of the day, x and y have different their values of exchange, and then temp goes away. Because temp lasts until where? What is the lifespan of temp? When does temp cease to exist? Like a parrot in the Monty Python sketch. How long does temp last for? When does it go away? If I tried scouting temp down here, does this work? No. Until it's used? No. Temp is undeclared. And the reason why it's undeclared is because variables live within their scope. So variables live until the close of their scope. So this guy is going to live until that curly brace right there. That's the end of temp's life. So temp does not exist down here. It's gone. It's been deallocated. It's not. It has ceased to be. So temp lives until here. Yep. Every variable lives within its curly braces. Okay. And so this is a classic swap algorithm. If you want to do it without the temporary variable, you can do so using the algebra trick. Let's take a look here. So that's correct, but you forgot to put the integers here. So you can't just say reference x, reference y like that. You actually have to say integer reference x, integer reference y. Possibly that would work if you're doing like 1970s era C. Old C style code actually did not require variable types. It would just assume you meant int if you didn't have a type on it. But as you can see here, it doesn't like it these days. Modern C++ requires you to have a type, and ampersand by itself is not a type. You have to say it is an integer reference or a float reference or something like that for that to work. So let's see what else here. Tripler is correct. I would not put the C out there. So one thing that's really important is like students oftentimes get confused C outing a value and like doing something with the value. Possibly because they did Python, and Python, if you triple value, it automatically prints it to the screen. But in my opinion, you don't want to put C out statements like that, except maybe if you're doing debugging or something. But like in general, a tripler takes a value in, triples it, and then that's it. It doesn't have to return anything because the original variable has been tripled because you did successfully put it by reference here. So swap, yeah, you can't do that. And always initialize your variables. That's something that is okay here, Romero. And a lot of people write code this way. Zybooks writes code this way, which is unfortunate. But yeah, always initialize your variables, even if you're immediately going to see into them. Like usually a couple times per week, there are students who post code onto the Help Center. And the reason why their code's not working is because they didn't write equals 0 on it. In this case, your code is perfectly fine doing int I and cin into I. That is just fine. I just highly recommend students put the equals 0 on it all the time so that you just get into the habit of always having initialized variables. Let's see here. Herbart. Triple is correct. Swap. You have to have an integer there also. You can't just say int by reference x, reference y. This is also something that is very common for students to do. Like if you have 3 integers, x, y, and z, people want to write int x, comma, y, comma, z, and you can't not in a function parameter. It has to be integer x, comma, integer y, comma, integer z. So, yeah. So you can't just write ampersand y there. It has to be integer ampersand y. Temp equals x, temp2 equals y, x equals y. No, you can't do this. You can't do this. So like, let's say x was 10 and y is 20. X is going to be set equal to 20, and then y is going to be set equal to 20, because you just set x. You probably meant to say temp here, right? You probably meant to say temp2 here. You don't technically need temp2. You just do y. So yeah, that there should be temp. And temp2 could probably be struck from the record. Main, goofy1, goofy2. Again, initialize your variables. It's something that you'll just see me harping on, even though it doesn't matter. You know, in this case, like your code's perfectly fine. Like with Romero's, your code's fine. There's no problem with it. I'm still going to harp on you to always initialize your integers to 0, because it works until it doesn't. I've been to Mount Moria. I've seen Mount Doom. I've been through the mines of Moria. Sorry, I've seen Mount Doom. Across the fields of Ether. Like, trust me on this one. I've been through the fires and the flames. Like, you want to always initialize your variables. It's just, take it from me, please. Always initialize your variables, even if you think that your code's fine. All right, so, and it also indent, GG equals capital G on that one. Let's see here. Z equals x, x equals y, y equals z. Yep, that's fine, but you need ints here as well. Int reference x, int reference y. And same on that. That looks fine to me. Int the, int me, int it. When, me, it. I don't know. You gotta initialize these variables, and I have some issues with the variable names. I've said it before, but like my TA when I was taking this class at UC San Diego, he would mark you off an entire letter grade if he didn't like your variable names. And I kind of swore not to do that, right? So if I don't like your variable names, I'll tell you, but I'm not gonna mark you down for it. I grade purely on correctness, okay? So I don't grade on effort. I don't care how many hours you spent on a homework assignment. I grade on, did you get it to work? Okay. So variable names, indentation, comments, that kind of stuff. I will certainly give you my opinion on it. I'm not going to, I don't grade people down on it, because your grade is your grade. My TA also never heard of Green Day, and this was like during the Dookie days when like Longview and Basket Case and all those other great Green Day songs that come out, and I kind of swore never to be like my TA. He was sort of an inspiration to do better. than be a clueless computer science guy who has no idea of what's going on in the world. So yeah, the variables here, I would initialize them, and the variable names I'm not really huge fan of. Triple, yeah, that's correct, and you're calling the standard library swap, which is hilarious. So yeah, that works just fine. So the standard library has the swap function. You can just call swap. You can do so without a temporary variable. Good on you. Okay. Okay, so that looks pretty good to me. Yeah, so like I said, Zybooks are going to be a little bit easier in the future, but you really have to, like, if you skipped any of the Zybooks, you should go back and do them. Because it's all going to come up. Like, you can't, like, miss branches or something, you should be able to do all of the programming assignments, and if you can't, Mincarelli is going to post a series of videos on the harder ones and give you like 80% of the solution. So again, thank Mincarelli. He works really hard. I don't demand that he works this hard. It's like he and I both kind of share the same work ethic, I think. We're always willing to work really hard so that you guys learn. I don't have to be answering Discord questions at 12:30 in the morning. I just do it because I really want you to learn. And Mincarelli, I think, is a lot like me, and he's always willing to go above and beyond and really work hard for you guys. Like, we're not paying him to make these videos; he's just doing it. So, be very, give some clap emojis to him, and thank him when you see him in real life, and buy him some cookies or something. He brought in cookies for the 12 o'clock class, which is the opposite of how it should be, right? Like, I think they should have been buying him like some key lime pie or something, but he brought in cookies for the 12 o'clock class. So. Okay, so that's it for today. Call by value and call by reference. A little bit of terminology. L value, R value, and void functions. That's what we covered today. And you honestly don't want anyone to fail. I don't either. Yeah, Mincarelli and I are a lot alike. Key lime pie does sound good. I'll go get some right now. It's a hot day. Wish you can make in-person classes. Yeah, if you can. Like, I think there's some benefit to being in person. There really is, because like we can walk around and see what students are doing. Today I didn't, because I was playing Green Day in class. Usually I do, and I can see what people are typing on the screen. And, not everybody in this class. 2, 3, 4, 5, 6, 7, 8, 9. Yeah, 9 people out of the 19 streaming posted their code. So don't think I'm not seeing that. You know what I mean? Like, if you're sitting there not typing anything, like during lab time, like you got to. That's what lab time is for. So if you get stuck or not, you can ask for help. Okay. Nobody gets through computer science without asking for help. It's very important. So don't do the Clovis Unified School District thing where you gotta instantly get something immediately and understand it and not ask for help and stuff like that, because it's a bad habit. Okay, so that's it for today, and I will see you guys on Friday. Peace out.